in this question we are given a tree and we have to return if this tree is height balanced or not. So basically let me just read out the definition. So what the definition of height balance is given in the question is a binary tree in which the depth of two subtrees of every node never differs more than one. So let me just translate what this question is saying. Like if you take a subtree, for example, like this is your subtree, and the difference of the like from the left hand side and the right hand side, or the number of depth of left side and the right hand side shouldn't differ more than one. Like if you take this subtree 20, 15 and 7, so depth on your the left side is 1, okay, and depth on the right side is 1. If we increase another node, for example, if we have let us suppose 10, so depth of depth of nodes on the left hand side is 2 and on the right hand side it's still 1, and this is still a balanced binary tree and will return a true. Why? In this case, because difference of these two from the left hand side and the right hand side is not more than 1, it's coming 1. If we take absolute, it's coming 1, and if it is greater than 1, then you will return false. It's a pretty simple question. You don't need to even see the code, you will just think, but the thing is you have to create the intuition. So if I explain it more in detail, like how you'll approach this problem. So basically what you have to find, you have to find the maximum number of node from any given node in the left side and the right side. Like you have this node, you'll find how much nodes or how much depth you have from the left side and the right side. So like if you heard of depth, simple, you use a DFS algorithm to traverse in depthwise manner. So for each subtree or for each node, you will do this because you have to check for each and every node. That's how you can find if the whole tree is balanced or not. And at last, if like this node is also balanced, this is also balanced, these all nodes are balanced, at last you return true. If some of the nodes is not balanced or some of the subtree is not balanced, you'll simply return false. Okay, it's pretty simple, but thinking is how you are thinking this problem. So you thought DFS and you will count the node, and in it will be a pretty simple DFS traversal. Like you write a function, you'll find pass a root node, and it will return you a int. And what will be your base case? Like if you found null, what you should return to its parent? Simply you return 0. If root is equals to null, return 0, it will return 0 to the parent. Okay, and if there is a node, what should we return? It should be return plus 1, na? Definitely. So we can have if root arrow left is there, like let us suppose we are standing here, we are going on the left hand side, we came here 9, and at last I hope this is clear to you. Let me just rub few of the lines. So this will return 0 to its parent, or let me use a different marker in this case. So you will return 0 to the parent, 0 to the parent. What should it return to its own parent? So we'll just think about that. It should simply return like one node is there, so 1 plus the value its DFS traversal is giving. Like it will tell I am a node, our node, and below that it will be given by the function recursive call. And similarly for the right, like if you come here, this will tell I am one node, and below me you can find the depth in the manner. Like if you don't understand, I'm going to explain, just wait. let me explain. Don't think about this tree, just think about a subtree that I just told. Okay, this don't have any left child or right child, return 0 to 15. Okay, and similarly with this case, no child, so it will return 0 left and right. Okay, this statement will work. And left side gives 0, right side gives 0, and what it should return to its parent is basically 1, or rather we shouldn't write 1 here, we can write just simple function, and like it left gave you 0, right gave you 0, and this will be giving you 1. I am a node. Okay, this will give you 1. Okay, and before 20 sending its parent key, I have this much of depth. Okay, it should check if it is height balanced or not, because this is also a tree. If you look, it is a subtree and it is a tree, so it will check if it is height balanced or not. So you can take a flag variable. I'm just writing the code. If absolute value of L minus R greater than 1, so you can set flag equals to false, or you can set a flag equals to false, which means the tree is not height balanced. Like if there is one more node or 2 more nodes, for example, it will give 1, 2, and it will give 3, it will give 1. So 3 minus 1 will be giving you 2. 2 is greater than 1, true. So the tree is not balanced. You will return false. You will set flag equals to false. And what should it return to parent? Just think about that for a second. So basically it will return the 1. Okay, 1 plus max of L comma R. Now why L comma R? Like it's getting messier in this small code. Like it gave you 1 and this will give you 3, or let us suppose it gave you 2. That will be much better approach. Like it gave you 2 and this one gave you 1, so it is still height balanced because 2 minus 1 is less than or equals to 1. It is not greater than 1, it's still 1. Okay, this won't work, like this flag won't be set. This tree is still balanced. Okay, it's balanced, and 20 will tell its parent key the maximum depth you can get from my side. What can be the maximum depth? So it will be always giving the maximum value of left or right. That's why I have written max L comma R plus 1, which will be this node itself. Like this is giving 2 and this is giving 1. So this parent want to check if this left hand side and this right hand side is balanced or not. So left hand will be giving you 1, right hand will be giving maximum depth, which is 2 because of this node depth, plus 1 which is this node also. So it will give you 3. So 1 minus 3, which will give you absolute 2, which is greater than 1. So flag will be set false. So basically what this question wants, or what you should approach, is a DFS traversal, because you have to find the depth. And what you want to just return a max, like at every level or at every subtree, you are checking if the value given from left hand side and the value from the right hand side is not greater than 1. If it is greater than 1, simply it is not balanced. If it is 1 or less than 1, the tree is simply balanced, and it will return the maximum depth till that node plus 1 because of that node. Let me show you the simple code. This is the simple code. As you can see, it is same as that. So simply you are having a balanced variable which is a boolean variable, and you set it to true because you are assuming that tree is balanced. And as you can see, it's a similar code. I forgot to just write this in the code. And you are doing nothing but you are doing a reverse traversal, going to the left, finding the depth from the left side, and from the right side you are checking if the difference is greater than once, which means it is not balanced. You'll set balance equals to false, and to the parent node you are returning the maximum depth for till that node, like at 20. Let us suppose left is giving you 2 and right is giving you 1. So you will return 2, which will be the maximum depth, plus 1 because of that node. And at last you will return the balanced, if the tree is balanced or not. So thanks for watching.